Hello, welcome back. In this lesson, we are going to learn about introduction to signals. So let's look at the agenda. We will be learning about what signal is all about, then analog signal, after that digital signal, continuous time signal, discrete time signal. So what is a signal? A signal basically is a waveform. If we have a data suppose the values are 0, 1, 0, 1, 1, 0, 0, 1, 1, 0. This is a data. Now this data cannot be passed through the transmission medium. In order that this data is passed through the transmission medium, we have to superimpose one carrier signal over this data. This carrier signal is basically a sinusoidal signal of high frequency. So let's say we are incorporating one sine wave and we are multiplying this sine wave with the above signal. So we can call it, this is the CT or the carrier signal. This is the message M. And in order that we convert it to a signal, this message M has to be multiplied by this carrier. Now when it gets multiplied by this carrier, what happens? We are getting, in place of zeros, so this is a zero pulse, so let's say 0 to V volt. These are basically pulses. So 0 to V volt, whenever there is a 0, even if you multiply with any frequency, it will be 0. Now whenever there is a 1 volt, whatever the value of the signal frequency is, this will be repeated here. Again we have 0, again we have 1 here. Again 1, 0, 0, then again 1 and 0. So we have been able to convert this data to a signal here. This is the data, M is the data and its corresponding signal is MT. So whenever the data is converted to a waveform to be able to be passed through the transmission medium as per the signaling condition or the frequency that is supported by that particular transmission medium, we call it a signal. What are the different types of signals? Signals can be of analog type or it can be of digital type. An analog type of signal, basically it is called a continuous time signal, and continuous time signal exists at each and every instant of time. And digital signal, basically it is a discrete time signal and it exists at certain instants of time. So this is one way of representing signal types like analog signal and digital signal. We will learn in more details about the analog signal and digital signal. Let us learn what analog signal is all about. Now, analog signal, we can just, let me draw one signal here. This is also an analog signal, example of analog signal. We can see that along the y-axis, we are plotting the amplitude of the signal. Along the x-axis, let's say we are plotting time of the signal. So this is analog in the sense that along the y-axis, you can have infinite number of values of the signal. So that is why it is analog in nature and it is continuous in nature, because the signal exists at each and every time instance, t1, t2, tn. So this is the nature of analog signal. This is also an analog signal. This is also an analog signal. Along the x-axis, we are plotting time. Along the y-axis, we are plotting the amplitude. Let us now understand a digital signal. A digital signal basically is a signal which has finite number of levels along the y-axis. So along the y-axis, we are plotting the amplitude. Along the x-axis, we are plotting the time. So if it has some levels like 0 and 1, so we draw it like this: 0, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 0, 0, 1. So this is a digital signal in the sense that there are only two levels of the signal, 0 level and the 1 level. So it is having a finite number of levels along the y-axis. Now along the x-axis, it exists for each and every interval of time. So it is a digital continuous signal, continuous time signal. So let me draw another example of digital signal. Here, let's say we have 0, 1, 2. There are three levels along the y-axis, which is basically the amplitude axis. And along the x-axis, it is the time axis, we have the signal. Let's draw it like this. So here we can see that this signal is having the values 1, 0, 2, 2, 0, 1, 1, 0, 2. So there are three levels, and three levels means the finite number of levels along the y-axis. So this is again a digital signal because along the y-axis, the number of levels is finite. Along the x-axis, we can see that the signal exists for each and every instant of time. So we can say that this is a continuous time signal. So digital but continuous time signal. So let us understand in detail the continuous time signal. This continuous time signal can be analog in nature or it can also be digital in nature. Let us first draw. Here along the x-axis we are plotting time. Along the y-axis we are plotting the amplitude. So if we draw it like this, this is an example. Let's say we write it as ft. So the signal is ft along, and here we are plotting time t. So starting from 0, this signal you see exists at each and every instant of time. So this is an example of continuous time signal. At the same time, the signal is analog in nature because along the y-axis, it has infinite number of levels. So this is continuous analog signal. We can also have a signal like this. One, 0, 1, 1, 0, 0, 1, 1, 1. So this is the time axis. This is the amplitude axis. We can see here that there are only two levels. So this is again a continuous time signal because the signal exists at each and every instant of time. And we are having a waveform. Along the y-axis, it has only two levels. So this is continuous digital signal. Continuous in the sense it is continuous time analog signal and this is continuous time digital signal. Next we understand what is discrete time signal. Discrete time signal can again be analog in nature or it can also be digital in nature. So along the time axis, we are plotting the time along the x-axis, and along the y-axis we are plotting the amplitude. So since this is discrete in nature, it will not exist at each and every instant of time. So let's say about the previous one, we can have it like this. Let's draw it like this. So this is basically a discrete signal because the signal exists only at this instance of time t1, t2, t3. And between t1 and t2 and t3, the signal does not exist. So these are basically the sample values of the signal. So this is a discrete time signal. At the same time, this is analog in nature. Why? Because along the y-axis, we can see that it can take on infinite number of levels. Infinite number of levels are there along the y-axis. So this is discrete time analog signal. We can also have discrete time digital signal like this. If there are only two levels and the signal exists only at these points, so at instance t1, t2, t3, the signal exists. So signal basically is, this is the one value of the signal. This is the 0th value. This is again 1, 0, 1 and 1. So there are only two levels of the signal value along the amplitude axis. So this is basically a digital signal, but it is at the same time discrete time because the signal is not available at all the points along the time axis. For example, between t1 and t2, there is no value of the signal. The signal value only exists at t1, t2, t3, t4 and so on. So in between these two time instance, there is no signal. So this is an example of digital discrete time signal. So here we come to the end of this lesson. In this lesson, we have learned about what signal is. Now we have learned about analog signal. We have learned about the meaning of digital signal. We have understood the 4 different categories of signal like analog, continuous, time signal, analog, discrete time signals, digital discrete time signal, and digital continuous time signal. Thank you.